Hello, Assalamu alaikum, good morning. And today I'm going to meet you to explain about the next section, which is section 1.8. I hope you all are fine. And this section deals about the area between the curves. So in area between the curves, we have just 3 questions. I'll just explain one by one. This is based on integration and the graphical representation. First, we have to find the area based on the integration methods, and then we draw it by graphical method. So probably you all well versed in drawing a graph, so this would be a further easier topic to explain. And this is the first question number 1, section 11.8, page 610. The question goes like this: use the definite integral to find the area of the region bounded by the given curve. To solve this question, we have to use a definite integration methods. I just would like to recollect our idea about what you mean by definite integral. So we have a limits. So we learned about the indefinite integral. Now it's a definite integral. We must have limits. So how to solve a limit or definite integral? First, find the integration and then apply the upper limit minus of lower limit. So this is the basic idea behind it. So please review the previous topic so that this questions will be furthermore easier for you. So let me start with the first question number 1, page 610. The function is y is equal to 5x plus 2, and they've given the limits x equal to 1 comma x equal to 4. Therefore, how to calculate the area? The area equal to integral of 1 to 4 into 5x plus 2 into dx. So we know that how to solve this question. It's a very simple question. So first, separate the addition. This is a simple arithmetic operation, is an addition. So separate it. Therefore, you'll get 5x plus dx plus integral of 1 to 4 into 2 into dx. And so what can we do if it is 2 into dx? 5x dx, 5 is a constant, take outside, and the remaining is x dx, and here 2 is constant, take outside, the remaining is dx. So when you do the integration for x dx, we know the formula, basic formula for integration: x power n is equal to x power n plus 1 divided by n plus 1. In this question here n is 1, therefore x power 1 plus 1 divided by 1 plus 1, x square divided by 2, plus integral of dx, the value is x. We must apply the limits also, 1 and 4. So here it is, I have taken again 1 by 2 outside because it's a constant, and x square, here it is x. So apply the upper limit, 4 square minus of 1 square plus 2 into, here is also apply the upper limit, 4 minus 1. So 4 square is 16, 1 square is minus 1, and 2 into 4 minus 3 is 3. 5 divided by 2 into 15 plus 6, 75 by 2 plus 6, 87 by 2, or when you use a calculator, will get a value of 43.5. So now we need to draw a graph for this. So identify any two sets of values, range of values for x and y. I'm starting with minus so that the graph will be passing through the entire region of negative and positive areas. So I just started with minus 1. If it is x is minus 1, what is the value of y? Substitute here. So 5 minus 1 plus 2. Therefore minus 5 plus 2 is equal to minus 3. And then if it is 0, how much is the value? 1, what is the value of y? 2, what's the value of y? And 3, what's the value of y? And 4, what's the value of y? So I have taken a series of a range of value. So there is no confusion in this topic, I mean in this section, because many of you having doubt why I have to take minus 1. Can I take minus 2? Yes, of course you can. You just take a particular range from, but it must cover a negative to a positive value. That's the only idea, so that the graph will pass through the entire region. So now you plot the graph. So take the range, you identify any range. Here the y-axis range from 5, 10, 15, 20, 25, and the x-axis minus 5, minus 10, and here in the y-axis negative region, and the x-axis 1, 2, 3, 4, because I am seeing here all the values are from minus 1 to 4. So therefore it is smallest range, and for the y-axis it goes up to 22. Therefore I have taken a longer range. Now plot the values: minus 1, minus 3. So here it is minus 1, and the minus 3 is almost here, and then 0, it is 2. For if it is 0, the value will be 2. So here it is 2, and then 1, it is 7. Therefore 1, it is 7. Plot all the values, connect with a straight line, and then shade the portion between the range of 1 to 4. Why? Because they've given very clearly the limit, the axis between 1 to 4. So just to identify the area on the x-axis between 1 to 4 and shade it. That is the equation, or the area between the curves for the function y is equal to 5x plus 2 between 1 to 4. So this is for the first question. Now we'll go to the third question. We must do the same thing for every question because all the functions are same. Here y is equal to 3x square. Question number 3, y is equal to 3x square, and the range is x equal to 1 to x equal to 3, and the same page number 610. The first thing is find the area between the definite region 1 to 3, 3x square. 3 is a constant, take outside and integrate x square, which will be x square by 3. Apply the upper limit and the lower limit. Upper limit is 3, therefore it will be 3 cube minus 1. 3 cube is 27 minus 1. The answer is 26. Now we got the area between the curve. So how to plot the region or plot the area? Identify two range of values from x and y. Suppose x is minus 4. What's the value of y? And if it is minus 3, substitute the value of x here, and what's the value? I've taken between minus 4 to plus 4, because you see very evenly it is arranged, taken from negative value of minus 4 to the positive value of plus 4. So we get a series of data, plot the value. So take the range for the x-axis, and the x-axis 1 2 3 4 5 and minus 1 2, because you can see the x values are minus 4 to plus 4, and the y values are, it is going up to plus 48 to plus 48. So 48 to 48. So I have taken 60 10 in the range of 10 20 30, and minus 10 20 30. So the whole range is between plus to plus. Therefore you just plot the values. If it is minus 4, then y is plus 48. So minus 4 and then plus 48. Minus 3, what's the value? Minus 2, minus 1, and the 0 also this. For 0 the value is 0, it is plotted. 1, it's 3. For 1 it is 3, and then it is 2, it's 12. It goes on, so that you will get a range, and you have to shade the portion. This is the most important part you have to do. Shading between 1 to 3. Why it is 1 to 3? Because the range is given, the x-axis, the range is the curve is passing between 1 to 3. So just shade the portion. This is the equation or the area between the curve for the given function y is equal to 3x square. And the last question is the second one, question number 2, y is equal to x plus 5 between the range 2 to 4. So first integrate 2 to 4 x plus 5 into dx. X, separate the function, x plus 5 into dx. So when you do the integration for x, it is x square by 2. Do the integration for dx, it is x. Apply the upper limit 4 and the lower limit minus 2, and then the upper limit is 4 here, lower limit is minus 2. So when you substitute all the values and square it and subtract, you will get 16. Again you take a range of value for x and y. So I started from minus 4. For minus 4, if I apply minus 4 plus 5, it is plus 1, and then minus 3, minus 2, 1 0 1 2 3 plus. So we get a negative to positive range, and I got the y value also. Now again you take the range for the x-axis is 1 2 3 4 5 6 and minus 1 to 6, and the y-axis is start from 2 to 12, because the range is going up to 9. Therefore I have taken 1 to 9, therefore positive values. Plot all the values. Minus 4 it's 1, and minus 3 it's 2, minus 2 it's 3, and then minus 1 is 4. For 0 it is 5. So this is a curve. Just to connect the lines with the help of a ruler, and then shade the portion between 2 to 4, because the range is given as 2 to 4. So I've shaded the portion, and this is the area between the curve for the given function y is equal to x plus 5. So this is the way you have to solve the topic. This will be quite easy, so you can easily solve it. Please study again one more time and cover all the topics, and good luck. Thank you.